All right, good. So the live is on in Facebook.
Is the URL on the chat?
No, I'll add the URL because
Okay.
the URL comes only when the live begins.
After some time, is it?
Yeah,
Okay.
yeah,
Okay.
yeah. All right. So I think I got the Facebook URL. I'm just checking the YouTube one. Then we can get started. Okay, perfect. So we are live. Um, All right. So, Rayana, please take care of the waiting room. Whoever wants to join, please admit them. And I'm gonna make Balaprasad Anna. I'm going to make you as co-host. If you can help with the waiting room, please. All right. So let's get started. Um, Thank you, everyone, for joining this session. It is being organized by Global NRI Forum. We are, mostly Ambedkarites and some like-minded people who wants to, spend some time on employability skills so that we can share what we are doing in the industry because all of us are into IT industry, IT and software industry. So we want to share the real-time experience with the aspiring students who are, interested in getting into IT and software industries. So with that, we have started this Learning Edge series. And this is the first session. We are going to talk about cloud computing, and it is going to be an introduction session. And we have our guest Ramakrishna Bhupati. He works for IBM Red Hat. He is based out of California, Santa Clara, California. Um, I would like to request Raidas Mantena. Raina, you're there?
Yeah. Sorry,
To
yeah.
yeah. Can you please quickly introduce
Yeah.
our
Yeah.
speaker and if you can talk about a minute about why we are doing this, then we can kick off the session.
Yeah.
Thank you.
Thank you. Thank you, Rashikar. Thank you for all the coordination efforts. Hello, everybody. My name is Raidas Mantina. People call me Roy. So it is an honor, opportunity for me to interact with you all. So basically, we after coming to America, so we always wonder how we can reach out to our people back home. ఏదో విధంగా what we have learned, you know, in terms of subject matters, kani, we wanted to give back to the society. And right now, the ఇప్పుడున్న పరిస్థితుల్లో the trend is technology, everything. It's not only just IT. Every department, whether it's agriculture, aerospace, or pharmaceutical, every industry going through the transformation, embracing the technology. So with that, you all know that the public sector is not in a position to give jobs to anybody. I don't think they have even a 1 or 2% of jobs these days. Everything is becoming privatization, sold out. So in this, and there are more educated coming, and there are less jobs and more unemployment. So we thought, let's create a series of training sessions centered around latest technologies, cloud computing, and blockchain, cryptocurrencies, and Java, .NET. And, we thought, this can be done with not much money investment. It's mostly time and talent that can be done easily. So we reached out to like-minded friends, those who are experts on cloud, .NET, Java, and they also liked it. They're already doing these programs, but we thought, hey, let's come together. Let's do it as a team. So that's how this initiative came forward. And Rashekar Kadari spent a lot of time and efforts, putting together this meeting and the coordination. And this is a first meeting, and our goal is very simple. to train you, teach you, lead you into certification. And certifications are highly valuable. Certification proves that you are worth to the organization. In fact, if you are employed already, then there is a research proven that the certification actually helps you to gain edge. In some cases, raise your salary by 15 to 20%. So for those, we help you to, you know, Ramakrishna, for example, is a cloud expert. He will help you. Within cloud, you have Azure, Google, and AWS, and he'll be able to lead you resources and forums, all that stuff. And also, for those certification and employable skills, basically. You're a .NET, you could add on Python, or if you're a Java, you can add on cloud. And these days, the other thing I want to share with you all, many of you are younger. These days, it's not easy to get a job just by posting a resume online. You need to network. Coming to this meeting, you'll come to know who is Ramakrishna, you'll come to know who is Rajshekhar, Sandeep, Bala. So these people will become network. You can start in this call offline, you can ask for their phone number, email. So there's so much. Not only you're learning technology, you are networking with people. So with that, and I myself is an Ambedkarite. I used the benefits of his reservation and the Constitution, and I love India, though I live. So we want to give something back to the society, and especially to the youth. Because you are the future. Please use these training sessions effectively and talk to people and get benefit out of it. And coming to the today's trainer, Ramakrishna Bhupati is my good friend. I know him for more than 15 years, and he has a lot of in-depth experience and knowledge in various technologies. And he's a trainer. He trains within the company and with some corporations. And with that, much further ado, I would like to request Ramakrishna to introduce and take it from there. And I request you all, please, ask questions and share with your friends. This is first meeting, and we are very committed. We are not like just one meeting we are done. We have a really good vision for this program, and we are, if things all work out, we are going to even partner with some universities and some corporations to help you place into jobs. And Bala is doing a wonderful job in India, and we requested his help with this program to reach on the ground. And with that, thank you very much. Thank you, Rajshekhar, and for leading this effort.
Yep.
Yeah.
Thank you very much, Raina, for the introduction and giving the background for this initiative. So I'm gonna hand over the host to our guest, Ramakrishna Bhupati. And yeah, before I do that, just one thing. We are streaming this live in Facebook as well as the YouTube. So if anybody is not able to join into the Zoom, please watch the YouTube and Facebook live, and you can comment your questions either in the Zoom chat here, or Facebook live, or YouTube live. You can post your question anywhere. I will be reading all those questions and get it answered by our instructor today. So any questions will be taken toward the end of the session. So the first, this is going to be a 2-hour session. So for the first 1.5 hour, like 90 minutes, we are going to focus on the content that is going to be covered today, and then in the last 30 minutes we can take the Q&A. So during the course of the presentation, please feel free to post your questions in any of the channels that I've just said. Okay, and like Raidas Mantena said, we are here. So if you have any questions, need network guidance, even after this session, and for those who are watching this recorded live later today, please feel free to contact us. We are here to help you. The whole purpose of this session is to give you a channel to learn new technologies. I know there are a lot of sources out there, like if you go YouTube, Google, there are a lot of things out there, but this is instructor led, and those who are part of it are already real time industry experts, so you will get a very good insights rather than watching a recorded live, right? So that is the whole purpose. So without any ado, I'm going to make our instructor today, Ramakrishna Bhupati, as host, and he will take it over from here. Rama, all yours.
Okay, thanks, guys. Thanks, Rashik. I think I'm now the host, and thanks, Roy, for the introduction and the noble efforts that you're trying to put in. And I see that you're a Manchester United fan. I'm with Paris Saint Germain.
Yes.
So I think I'm following up with the Championships League semifinals, the next leg. Okay. So let's get started. So let me start sharing my screen.
And before you start, Rama, can you please make me as co-host? Because when I transferred, I lost the
Sure, definitely I will do that.
Yeah.
Let me.
Yeah, you can go to participants list and you can find me.
Rashikar, okay.
Yeah, Rashikar,
make co-host.
Co-host, yes.
Okay.
Yeah.
Okay. Thank you very much. There are two people waiting to be admitted.
I'll take care of those. You
okay,
can
no problem.
Yeah,
Thank
you
you
can
very
proceed
much.
with the presentation.
Okay.
I'll take care of those.
Now, okay, you can see my presentation.
Yes, we can.
Okay, I can see my screen right now. Let me do that and present. Okay. Good morning and good evening, guys. My name is Ramakrishna, and you can see whatever it is with my titles and all that. So I welcome you all to a session on cloud computing, and I'm pleased and excited to be here. So that's a brief intro about me, and I have been in the industry for more than 25 years, and previously I worked for AOL, Verity, Cisco, HP, and a few other startups. And I primarily started working on cloud technology since 2013. And my first foray into cloud technologies started with OpenStack. So OpenStack is primarily an infrastructure as a service product. That's where I had my hands-on experience, and then trying to understand cloud technologies. And since then, I have been working on cloud technologies. I primarily have a bachelor's degree in computer science and engineering from JNTU. And then 10 years back, I kind of wanted to do something exciting, and I went to business school and got my MBA, and haven't done much with it, but yeah. And I'm also an active hiker, and my most big hiking achievement was I hiked Mount Whitney, the tallest peak in North America, and and I also watch a lot of movies, movies, and I follow tennis and soccer, and I kind of keep changing my soccer club affiliations, and that's about it. And I'm also Google certified cloud architect. So that's about me. I think that's fair enough. So what's the agenda for today? So today we're going to talk about what cloud is, and why do we need cloud? Why is cloud getting popular, and so on. And then we look at the brief history and evolution of cloud. And then we will also look at the public cloud market. And we'll also talk briefly about virtualization. Now, this is important because that's what essentially fueled cloud. I mean, without virtualization, then there's no cloud. And then we talk about containerization and Kubernetes. It's all brief touch-ups. So primarily, it's looking at what's happening in the industry as of now. I think those who are trying to seek employment in cloud technology should at least be aware of this. And then we'll look at bunch of learning resources, as in like, I want to learn about cloud, so where do I start? Right? And then we'll also look at recent advancements and where is the future headed in terms of cloud technology. And then we'll follow up with Q&A, and I'll be following up on the chat. And if you have any question, do please post it there. So, what is cloud? So primarily, you keep hearing what's cloud. I mean, in a generic language, it's tough for people to understand what cloud is. So cloud computing is the use of hardware and software to deliver a service over a network. Now, the primary thing is that you're delivering a service, and then it is over the network, internet primarily. So the first thing is, it's not a resource that's actually sitting on your desktop or at home. Okay. Now you keep hearing, whenever you keep hearing about cloud, you keep hearing about SaaS, PaaS, and IaaS, and we'll talk about them subsequently. The evolution. Now, just to give a brief about how the history of cloud evolved. If you recall, in the 1960s, we had John McCarthy's time sharing mainframe systems. Essentially, there is one central mainframe located in some place, and then it's physically connected to a bunch of terminals, and then you do some kind of a time sharing. So you have dumb terminals, and then they interact with the main server, and the server is now powerful enough to handle multiple time shared resources. So it felt as if you were doing something by yourself, and then the server was attending to your requests exclusively. Now that's a kind of a primitive version of a cloud, I would say. But then subsequently, ARPANET came along, and that set up some networking standards, networking protocols were standardized. Sometime in 1970, a primitive version of virtualization started. It didn't take off much. Sometime in 1997, 1990, when we had this internet, public internet, www, World Wide Web, and so on. But in 1997, somebody by name Ramnath Chellappa, he kind of gave a first definition to cloud computing. Now, 1997, there wasn't that much of cloud, but then in 1999, when Salesforce started, they start offering what we call as software as a service. Now, if you don't know what software as a service, don't worry. We'll talk about it in detail. And then in 2006, Amazon launched EC2 and then storage, which are primarily the first publicly consumable cloud service started by Amazon. And then since then, a host of other companies started. We look at the business history and so on. And then now, if you look at how the cloud market is, it's exploding. It's exploding. Now, here is
quick question, Rama. Quick question, Rama. So, for the organizations, the cloud. So, what is the adoption rate? So,
okay, the adoption. Okay, we will actually I'll address this in the subsequent slides. Okay.
Okay. Thank you, Ram.
Yeah, no problem. So now, if you look at the cloud market, so if you look at this, how big is it? So if you look at the amount of how big is it? It's like 130 billion on an annual basis as of Q4 2020. There are a bunch of players, AWS, Azure, Google Cloud, and then there are plenty of other players. Now, the cloud adoption, as far as cloud adoption is concerned, I don't know the exact numbers of how fast it is, but almost every company wants to be on the cloud. Now, we look at why companies would want to be on the cloud in a second. Now, okay, yes, the market for cloud is exploding, and but why would anybody want to be on the cloud? So there are a bunch of reasons for that to happen. So primarily, it's services on demand. So what does that means services on demand. I mean, like for example, you are working on a high-profile project that needs lots of resources. Now you can talk to your manager and then provision this, and then in turn you would ask your admin to set up a bunch of machines, right? Now that would take sometimes days or weeks, and it's a very expensive affair, procuring the hardware and so on. But what if these services are available on demand? I need a bunch of machines. So what you do is you go to Amazon, and then everything can happen in a few minutes. So you would have like whatever computer resources you want, whatever network resources you want, and everything you can get it on demand. So that's a beautiful thing about cloud. It's like services on demand. So not only compute services, anything. So between Amazon, Google, and Azure from Microsoft, there are like at least 200 to 300 services being made available. I mean, anything you want, it's there, pretty much. Okay, and then ease of access and agility. Now, how do you access the resources? I think that's a important thing because these resources are available from your machine, and they're available 24 by 7, anytime. Okay, so that's a big thing. So that's a game changer. Elasticity and auto scaling. Now, this is what differentiates a kind of a private cloud versus public. I mean, although both of them provide elasticity and auto scaling, but when you go to public cloud, right, you have pretty much like infinite resources, and they auto scale. So, if you remember, like 10 years back, during the Thanksgiving Friday, you have this Black Friday sale, and I remember like Walmart website went down because it could not handle the load. But in a similar situation now, when there's a lot more load in your systems, right, your resources expand automatically, and those resources auto scale. Hey, I do hear some background noise. If you guys are not speaking, can you mute, please? Okay. And cheaper and better ROI. Okay. So it's all about better return on investment. It's like why is it cheaper and better ROI? It's primarily because when you would be needing resources and how much, and depending upon that, we can have a control on how many resources you would be needing and how much resources you need to control. It's highly secure. So if you look at how secure the cloud resources are, aside from the physical infrastructure security, in the remote corners of the world, these resources are highly secure. There is multiple level of scanning, entry points that will prevent you from accessing resources that you're not authorized to do, and so on and so forth. And global resource network of resources. So if you take Amazon or even Google for that matter, right, together they have close to around 40 regions around the world. Half a dozen in the United States, including India, China, not in China, but Japan, Southeast Asia, Europe, Africa. Okay, everywhere there are regional centers where your resources are being made available. Now the intent is that although it is cloud and then the resources are globally distributed, you still want to have as low of a you want service to be available very quickly. Like in milliseconds. You want this latency time. You want to be very minimal. So that's the reason you have resources very close to where the consumer actually lives. Okay. Easy backup and recovery. Now, one of the things that you I remember, 10, 15 years back, backup and recovery were like a painfully long process. Okay. Now we had automated systems in place, but then again, bringing up to the same state where it was before was like a painful process. Now, with the cloud, you have all these right there. So all with the click of a button, all these resources are backed up, and when you want it, and you can recover those resources. high availability. So I think this is one thing. Like what does high availability actually mean? It's about resources being available 24/7, redundant, and fault tolerant. It's like, okay, what happens if one of those servers, it dies? Like, so there is automatically some other service will pick it up, and some other node is quickly configured and being made available. And that's about high availability, because we didn't have this high availability like 10 to 15 years back. Because if your mail server needs an upgrade, then there's a turnaround time, and then it used to happen in the middle of the night, and then all of you will get an email that the service are not going to be available. But that's not the case anymore. It's all highly available. Okay. And the last and the more important is move from capex to opex. Is capital expenses to operational expenses. Now, why this happens is because, remember, if you're having to you're in the non-cloud scenario. Okay, so I see some scratches. I mean, somebody's writing on the screen. Okay, so move from capex to opex. So when you are not on cloud, let's say on-prem, for example, you have to make investments ahead of time. Like you have to procure machines, your network switches and routers, and then you have to assign some people, you have to hire employees, new employees, and so on. So that's a huge capital expense. I mean, you have no idea when you're going to be using this, right? And you have no idea when you would actually be able to realize your gains on this. Okay. Now, when you move from OPEX, so you spend as you move, you spend as you earn, kind of a situation. So you don't have to make commitments ahead of time, and that will actually be less pressure on your financial resources. Okay. Now, although cloud is exciting, and everybody wants to be on the cloud and so on, but there are a couple of challenges as far as the adoption is concerned. Now, adoption rate is going pretty fast, because these days every company that hear about they want to be on the cloud, but it only like when the situation is now. The government websites and then data centers are on the cloud, and pretty much every company I know of is in the cloud in some way or other. Now, there are challenges in terms of why some of the companies are not moving to cloud. So one of them is security and privacy. There are still some concerns, although they are not founded. I mean, it was a concern a couple of years back, but cloud is really secure and private now. So there's a lot of technological advancements in cloud security and so on. And in fact, cloud is a lot more secure than the on-prem infrastructure. So on-prem to keep data secure. So some companies don't want to share data. They just want to keep it themselves for whatever reason it is. Right? So that's another challenge. So they don't want to move to the cloud. Very low latency requirements. Sometimes you want, in some situations where your customers are not distributed globally but then locally, in which case you want your machine and infrastructure to be in the vicinity for very low latency requirements, or maybe some near real-time behavior. So you want to have it on-prem. Okay. Government regulation. Now, some of the countries in Europe, for example, like Germany, right? So Germany would insist that the data of all its citizens must be stored within the country, somewhere within Germany. So public cloud companies, if they want to tap on those kind of customers, then they must have a region in Germany. So that's a good example. So there's so plenty of regulations and so on. Or some companies may insist that although you may want to embrace cloud, but you would allow the applications to be running on the cloud, but the data should still be on-prem. So that's because of government regulation. Portability. Some applications that you developed on-prem may not be portable to the cloud. It could be the proprietary systems, or it's just the nature of the way your application has been designed. So that's again, there's a challenge of taking these kind of applications into the cloud. Again, proprietary systems. Proprietary systems, because you develop it in a language that only your company knows or your company uses. And if you move to the cloud and you don't have that kind of runtime platform there, so in which case it will be tough for you to go and host your applications on the cloud, right? So these are some of the challenges. We talked about service models briefly.
Rama, sorry for interruption, but quick question, just to engage the audience. If you can go back to the previous slide, um, can we can you cover some basic day-to-day cloud applications that we use, like Google Drive, Facebook, Gmail? Can you cover some examples
Yes.
that every
Yeah.
one of us can relate, right?
Yes,
Because
of course, I'll do that.
yeah.
Yeah.
So in my college days, I used to carry a CD drive or a USB to copy my project files or my trip photos and all. But now I'm not. I don't know when I used the USB last
Yeah.
time, right? So can
Yes.
you please cover that how it works?
Yeah, sure.
Yeah, and how it addresses some of these challenges.
Yeah. Now we touch upon SaaS, or SaaS and infrastructure service. Now, when you think about SaaS, what does actually SaaS is like? So, primarily, SaaS would have end users. So, how I distinguish is like, Gmail is a SaaS application. Office 365 is a SaaS application. So, what would you be doing to access SaaS applications? All you need is a username and a password, and you're inside. Like Dropbox, okay, box.net, they're again SaaS applications. So in case of Gmail, for example, you sign in and log in, and Google maintains the infrastructure behind the scene, right? Now you go to Google Drive, for example, again it's a SaaS application, and you store your files, in your folder on Drive, and then behind the scene, Google would have something like a network storage where it stores your applications, your data. Okay. Now, I know Google, for that matter, what it does is all its email, Gmail or My Drive or whatever, right? It stores at 3 different places, so that if one site goes down, then its information is fetched from another site. Now, if you look at how this happens, is all behind the scene there is a network storage, and then there is storage virtualization. Now, virtualization is a very big concept in itself, but I'm just touching upon it. Now, if you think how is this even possible, a lot of it is happening because of a concept called virtualization. Virtualization is across storage, across your network devices, okay, across your compute devices. Now, it's network virtualization is spreading everywhere. Now, all this is happening only because of virtualization, being able to provide redundant, reliable services. Now, we'll dig into virtualization a bit later, and so the next thing that you may have heard about is platform as a service. Now, this platform as a service is typically used by software developers. Now, end users, like the common man, is not aware of PaaS because he doesn't need to be aware of it. Now, what does PaaS actually do? Now, when you have a SaaS application like Gmail or whatever, right? It is hosted. It has to be hosted on some platform. Typically, that's what is called a platform as a service. Now, all of you software developers, what you would be doing is, this is where you will be working around. Mostly a PaaS is basically you develop platform as a service. You could also be developing applications, but primarily you will be, using something like Cloud Foundry, Heroku, or OpenShift, and then building applications on top of that, which SaaS users would be using. Like Gmail would be using some proprietary platform as a service. Okay, so that's where platform sits. Now, the big thing, infrastructure as a service. Now, this is the biggest component, because if you want a platform or a software, you need some hardware, right? You need hardware. What primarily you need? What you need? Compute devices. You need network devices. You need storage devices. So this is what infrastructure as service is. So primarily your network administrators and IT administrators would be working here. So primarily what these administrators would do is have a platform. Like for example, VMware is a infrastructure service platform. AWS, Azure are all infrastructure service platform. OpenStack is a platform, is a IaaS. So when you ask, when you want to find out what is IaaS and what is PaaS, it's like asking, hey, give me two computers, give me two virtual machines, give me a Kubernetes cluster. So that's where infrastructure service is. Okay, and platform as service would be like, hey, give me a database, give me a Hadoop service. So these are all platform as service. SaaS would be like, hey, give me access to email, give me access to a word processor. So that is a software service. Now, to go a bit deeper, software as service is a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. Now, right now, these days, whenever you want Microsoft Word, what would you be doing? You would just go and then log into Microsoft Office 365 and create an account and then pay your $5 or $10 a year service, and then you're online, right? That is a good example of software as a service. Now, what happened before? I mean, if you 10 years back, if you wanted Microsoft Office, what would you do? You would buy the software, which typically comes on a CD. I mean, this is what it used to come. You go to Price Electronics or other store like Best Buy, and then you buy Microsoft Office, and then it has CD, and then you pop the CD in your drive, and then install it and enter the license key. Okay, that is not software as a service. That is on-prem. Okay, so you install it on your laptop and then use it. Okay, now if you your laptop is at home and you're at office, right? You can't access your Microsoft Word. I mean, your office may provide you separate, but you cannot access the one that you install yourself. Now, so and then subsequently, years later, what happened, and all the same software was being available as a downloadable. So instead of coming in a CD, then you are getting it as a piece of binary that you download and install it on your laptop. Now, those are all not software as a service, because when you say service, remember we talked about it's available anywhere. Like for example, if you have Microsoft Office 365 account, you can go to your friend's laptop, log in, and then resume your work. Okay, you can go to public library. Okay, and then start accessing your Microsoft Word application. That is a true software, and it is being made available as a service. Okay, so now it's primarily a subscription model, which means you have to pay some fees on a time basis, every year, every month, whatever. And it's mostly dealt by end users and consumers. Now, the big software service that we know, Salesforce, ServiceNow, Workday, Atlassian, I mean even Gmail, and then there are plenty. Okay, they're all software service. Now, platform as service. Platform as service is a cloud computing model where a third-party provider delivers hardware and software tools to users over the internet. Here, in the past, right, it's mostly developers or engineers to be working here, and the end consumer is not working here. End consumer rarely is platform as service. Like in the SaaS, you're working on your application, whatever, and it stores the data somewhere, right? It has to store the data somewhere. It has to store your login session somewhere. It has to store the events when you log in, everything, some platform. That is where platform as service comes. Yeah. And again, this is on a subscription basis. A good platforms would be like Hadoop platform. Database is a platform as service. It's like, hey, give me a database. I need Oracle database, and then give me a link to the service endpoint. So that's a typical platform as a service. Now, the products that you have, Elastic, Beanstalk, VMware, Pivotal, Red Hat OpenShift, Cloud Foundry, these are all platform as a service. Now, infrastructure as a service. Now, for all these PaaS and SaaS survive, you need infrastructure. Infrastructure is primarily like, I need 20 machines, network together, and with 3 terabyte of storage. That's what infrastructure is primarily. So we're not talking about applications, we're not talking about databases, we're just talking about network, storage, and compute. That is where infrastructure service comes. So it's a cloud computing service model where enterprises rent or lease servers for compute, network, storage in the cloud. Typically, your network and IT admins manage these resources. So whether something service is a infrastructure service or platform services, you ask the question, what are we getting? If you're getting machinery, network, and storage, then that's infrastructure as service. Now, every cloud provider that I know of is providing this infrastructure service. So all this is good, this is fantastic. But what actually happened that people are moving to cloud, or something should have happened that cloud has become popular, right? It's not just about let's all put together all our resources at one place and make them available, right? But a lot of technologies would have been made available, be about redundancy, extracting more from the same hardware. It's all happened thanks to what we call virtualization. Now we briefly talked about virtualization. So what exactly is virtualization? So in a common man's language, right, it's about whatever hardware was doing, now it will be done by software. That's one simplistic example. And second thing is like whatever this particular switch or a computer now you can virtualize it and make it into multiple computers or multiple virtual switches. Now, in a layman's language, you have your laptop, it is a one machine, but imagine with virtualization software installed, you can convert that into multiple machines. You can host multiple machines inside one laptop. Now, that is called virtualization. Now, that technology started, in fact, the virtualization on compute was commercialized by VMware. Now, there's a story that goes around that Amazon, Jeff Bezos, when his company was expanding, he bought a lot of hardware, like so many computers. He bought high-end computers and then network gear, storage, and everything. Then he realized, man, what do I do with this? It's not like he can return them. Okay, so what did then? Just then, as around the time, virtualization started becoming popular. Like VMware came with its own hypervisor. So what Jeff Bezos did is, okay, why can't I set up a AWS? What morphed? That small idea when he had access infrastructure morphed into an idea that eventually now became Amazon AWS, which is now the biggest business unit of Amazon. It's like 48 billion revenue on an annual basis. Now think about how big that is, right? So AWS is a big company in itself. So, but this idea of starting AWS came because of virtualization. Now, when you think of virtualization, one thing that comes to your mind is hypervisors. Now, hypervisors is what will facilitate virtualization in compute device. Now, whatever has happened to compute has also happened across the infrastructure spectrum, including storage. Now, storage virtualization. Now, remember I said if you access Gmail and then your Gmail is stored in 3 different places. If one place goes down, let's imagine earthquake comes and destroys the Google's California data center. The Google will still be able to function because they have the same data replicated in Japan and some other place. It's true with all these companies. Now, how is that possible? Do you think they are physically copying it at three different places? And if you physically copy, how do you make sure that they're all in sync, right? And that's the important piece. So there's a whole infrastructure piece that makes all this possible, and that happened because of virtualization. And storage virtualization is a big piece. Now, if you store your documents in my drive, Google Drive, again, it's replicated in multiple places. And the reason it is easy to retrieve and redundancy and then fault tolerant. I mean, these are the big pieces that you need to know. When you think of virtualization, these are three things that uh, uh, facilitates key to virtualization. Now and virtualization has gone across the spectrum. Not only compute is taken over storage and including network devices. So back then, and a single switch was maybe could support like 4 or 8 customers to provide multi-tenancy. Now with virtualized switches, right, now that number has gone multiplied by 100 times. So you don't need that much of hardware. You can manage with much less hardware. Now when public cloud started becoming popular, and one of the things that came up with one of the things that you need obviously is enabled multi-tenancy. So multi-tenancy has gone from from nothing to somewhere unbelievable progress. Like for example, when you obtain a virtual machine from Amazon AWS, you get a virtual machine, but it may be sitting on a larger machine and it is sharing the resources with another dozen people who have requested a virtual machine, and you don't know about it. So the big thing is about multi-tenancy and isolation. Isolation is a big thing, right? If there's no isolation, then you're not secure. So that's what virtualization actually provided: multi-tenancy and isolation. That's a very important thing, and that's why you have Amazon would buy a very high-end machine and then rent it to create like a 30-40 virtual machines there and rent it out to different people, and they don't interfere with each other, and they cannot, and they don't know that there are some other guys sitting occupying the same machine. It's like apartments. I mean, in apartments in a large building, you know that there is somebody else, but apartment do provide some kind of isolation. No,
Rama, quick interruption. I know you've been in almost like 35 minutes into the session. Would like to open. So far, you covered the history and the technologies that are facilitating cloud. Can we take a couple of questions from audience?
Yes, definitely. Go ahead, please.
Yeah. So please, those who have a question, unmute yourself.
Actually, we can do one thing. Let the audience post questions on the chat, and then one of you can read it out, and then I'll answer them.
We'll do that also. So we'll do that also. You can post while instructor is in progress. You can post chat.
If there are questions piled up, we can answer them right now.
Right. So far, I don't see any questions, but we'll open up the floor, and please unmute yourself and ask the question. It's if you're not asking questions, that shows you know everything or you didn't get everything. So please ask the question, and then before he goes deeper into the cloud technologies. So Raj, hope you have unmuted folks.
No, like they can unmute themselves.
Right.
So if we unmute...
This is Sandeep. So while we get other questions, let me ask a question because
please, Sandeep, go ahead, Sandeep. Please.
Yeah, go ahead, Sandeep.
So Sandeep Loy has, in his comment in chat, he has mentioned that healthcare providers, particularly because of HIPAA regulations, they don't allow public clouds. So if at all even if you are using cloud, you have to use on-prem or on-premise cloud. So can you briefly tell can cloud be on-premise if it is on-premise private cloud and it's part of the company itself, right? So is there something called on-premise cloud?
Yeah. So on-prem, we actually, there's a slide on that. so basically, now you have cloud instances that are available on Amazon or Google or whatever, right? Now, if you want to set up your own cloud on-prem, okay, what you would do is you use something like a software like OpenStack. And what OpenStack will facilitate is you build a cluster of machines, and then you install OpenStack, and then you can have your own private cloud. Now, the difference between private cloud and public cloud is, now private cloud is obviously not elastic. I mean, it is elastic to some extent, but then you're still hitting the limits. What would you do, right? You can't. You have to buy new hardware, install it, and so on. Okay. And second thing with private cloud is, what do you actually provide other than the infrastructure service, right? So it would have limited services. You can still have private cloud. You will have limited services. But unlike if you go to public cloud, you have like 200 plus services.
Right. Yeah. Okay.
That's a big thing. And again, in private cloud, security is everything in your hands. So it's about you managing your own resources in private cloud. I mean, you can set it up, but there's a limit on how far you could go. And in fact, the definition of cloud is expanding so much that cloud is providing new stuff all the time. How much can you manage to do all this yourself? Now, why some companies, the health or whatever, why they have the private cloud is primarily because they don't want to share the data, or they don't want to put the data in the public cloud domain. That's their big concern. Now, I don't think low latency requirement is like a big concern for them, but primarily because they don't want to share customers' data, and then maybe if they lose, they'll end up in lawsuits. So yeah, you can still set up private cloud, but it's not the same as public cloud in terms of the services that are available. And I mean, as long as it meets your private cloud requirements, that's enough. Like for example, the big private cloud installations that I know of are like eBay and Walmart. So what eBay and Walmart did was they installed their own OpenStack, and they bought like 1,000 machines or whatever. And primarily they for internal consumption. A new employee joins and they'll get a virtual machine. So the services are very limited because they don't need anything more than that. They don't need some of the services that public cloud provides. So that's the thing.
Thank you, Rama.
Yeah,
so the other question, Rama, there's a question in the chat.
Sure.
Can a client move from one cloud to other cloud? And what are the risks involved?
Okay.
Is it possible? So the question is from the CSP perspective. So the question is from Nags and Wanket.
Okay.
Yeah.
Yes. So now there's something called something that is happening. It's called cloud native. Now we could talk about it later on. Now, what this cloud native means exactly is, being indifferent to which cloud provider you're using. Now, if you're already hosting on AWS, yes. If your application follows cloud native principles, then you pretty much can migrate from one cloud to another cloud. Now, there are some subtle differences here because some of the, like Google, Amazon, they have their own proprietary stuff, in which case they're not like lift and shift. Lift and shift is like you take your resources from here, from Amazon, and then just put it in a Google Cloud. Now, it is not possible all the time if you are using proprietary Google or proprietary AWS, but otherwise they're all compatible and portable. And for that to happen, you follow cloud native principles. So cloud native is all about being portability across clouds.
Yeah, thank you, Rama. There is one more question. So, I mean, if these questions are something you are going to cover in the course of your presentation, you can simply, give a high-level answer and cover
you can go to the questions. It's no problem.
Yeah. So the question is, what if multiple guest OS got overlapped virtually? Then the personal information will be messed up, right? So how do the companies like AWS manage this kind of situation?
I mean, there's no question of messing up information. I mean, so okay, there's no overlap. So with virtualization, right?
Mm-hmm.
See, all the virtual machines are sitting on a single physical node, but there's no overlap. Although there is sharing, but see, that's what virtualization has done. Virtualization, another thing virtualization has done is isolation. Your network traffic will not interfere with other. Your storage calls will not interfere with the other. Okay, your function calls will not interfere. They don't know about anything of each other. So if you're thinking that these VMSs will mixed up, no, that's not going to happen.
Okay.
Because that problem has already been solved ages ago, and that's what hypervisors are designed to do, to provide multi-tenant isolation. That's a big piece of
Yeah, so I mean, just for layman, in the layman terms, I'm trying to oversimplify that, the overlapping or virtualization part. So like you're building an apartment, like 4 floor apartment on the same land, though the land is sharing. Everybody has their own doors, locks, windows, so everybody can sit on their apartment. They cannot, I mean, they can step out, but they have their privacy. It's as simple as that, right?
Yeah. So it's not like like in apartment, you turn on the lights
Mm-hmm.
in your house, and it's not going to turn off the lights in some other apartment. So there's
Exactly.
nothing. Like your gas stove is yours.
Yeah. Yeah.
There's no interference. So
Exactly.
that's,
Yeah.
and
Yeah.
in fact, yeah, it is a lot more secure and isolated than even an apartment kind of situation. Because
Got it.
see, the fact that Google can provide this much of cloud with not much of hardware is something that is fairly sophisticated.
Yeah.
So yeah. So one of the big piece that made this possible is software-defined networking. Now, software-defined networking is like huge concept in itself. That
sorry, just Rama, this is Naksin again. The question I asked about the cloud service provider dependencies, all most of the companies in the cloud service platform providers are US based or maybe Western countries, right? So, government of India has empaneled a couple of companies for as to provide the services in India. AWS was one of the vendor which was recently added into that. And what was the thought process behind that was like the dependency on the cloud service provider. Like almost all my business critical applications and most of the data is hosting into the cloud. And what happens if this company is going to blackmail and the data is outside country or within, if it is inside the country, then how to handle such kind of things? You explained about the native, cloud native, compute native, right? But how practical it is?
So yeah, so okay, AWS has got regions. I gave the example of Germany. That Germany would insist that all the data that pertains to German citizens must stay in the country. So India may have a similar provision, and AWS will ensure that all the government data that is related to Indian citizens will stay within the country. So the Amazon would have their own regions. Amazon does have a region in Mumbai. Okay, so Amazon makes sure that all the data is stored within the country and it's not stored elsewhere. Okay, and the motive for that is the fear of security, and then the fear that some catastrophic event would happen that would make this data fall into our enemies, our rivals, or maybe Pakistan, for example. I don't know, like how to. So that may be the motive, and I think these fears will go away in sooner or later. Because remember, if you look back, companies were even reluctant to get into cloud. How can you store our data there? But now everybody is embracing cloud, and then I think governments will also sooner or later will change. Now, I don't know if that answered your question, or you can reframe your question again if anything I missed.
Yeah, I mean, just wanted to know like how easy and flexible it is in terms of technology to adopt, to move from one cloud service provider to another cloud service provider if any disaster happens.
Yeah, so one service provider to other service provider. Now, when you think about cloud native, right? So cloud native is something that all three companies support. It's about building portable software. Now, one of the thing, uh, let's say you have your database in MySQL uh, in AWS. It is a simple lift and shift into Azure. It's called lift and shift. You take your data, you export it, and then just put it inside, and then you change the service URL, and that's it. You're up and running, right? Now that's a very simplistic case. But now, if you want to use a big table, all your data is in big table format in Google, you can't really migrate them to Azure or Microsoft because AWS, because that similar platform doesn't exist there. These are proprietary. Now, jumping from one cloud to another cloud is not that common. But for smaller companies that want to save costs, either because they find the other cloud is cheaper, it's fairly easy. But there's not a lot of whole movement from one cloud to another. Like, Netflix has been using AWS for ages, right? And again, if you're using proprietary Google technologies, then you can't migrate them. But again, if you're following cloud native principles and then you're using Google Kubernetes, right? Now Kubernetes is there everywhere. So they're again portable across. So that's the example. Okay, so yeah, if you have further questions, we can actually take it to the end. I think let's move on.
Yeah, let's
okay,
move on.
Now other thing that that big pace is software-defined networking. When you think of SDN, Google has made the biggest achievements in SDN. It's being able to virtualize your switches and routers, and with that, now a single switch can handle multiple multi-tenancy networks. Okay, single switch, it's a huge number. Okay, now how is that possible now? Because whatever hardware routing was being done by the hardware, right now it is being done by software. So SDN would add a few more extra headers and then make sure that all the routing happens through software. Now that's a big jump in technology. Now that's why we are able to access resources from anywhere, provide the kind of isolation that we need, and so on. And then network function virtualization. That's I'm just mentioning it. We are not going to go deep. It's about creating a virtualized load balancer and so on. So, and the other big piece that happened the last 5 years is containers and Kubernetes, and then cloud native. So we saw this virtualization, and essentially, if you look at the traditional architecture, you have hardware, and then operating system, and then you have applications. Now it's now moving more towards hardware, and then a virtualization layer. So virtualization layer can mean network, storage, or compute, and then being able to provide multiple applications and multiple operating systems and so on top of that. Now, in all of this, right, one key thing that you should remember is that the industry is moving towards, okay, I want to get more juice out of the same resource. If you remember, as a kid, whenever I go to India, right, when I'm going on the streets or somewhere, whenever I see a sugarcane juice vendor, right, I'm excited how he does this juice. Okay, so this guy, can you mute, guys? If you're not talking.
Yeah.
Some background. Okay.
Yeah, I'll take care of that. You
can. Yeah. Okay. So essentially, the analogy I want to give was like that: the sugarcane vendor, right? He puts like 2 sticks into the crusher, and then he does it, and then he does it 3 times. Then I think he's done. But then he puts it for the 4th time, and then he's now struggling, and then he'll put it again, the husk with some juice in it, and then he'll extract juice. And you think, okay, there's nothing there in the sugar cane left out that you can get any juice, but he still managed to extract some juice, right? And after 5 attempts, it's like you have the bare bone, with no, absolutely not even a single atom of juice in there. So that is precisely what is happening to your machines, because and there is a relentless pursuit towards getting more and more out of the same resource. We're not building bigger machines. I mean, if you look at how the industry is moving, Intel is not building powerful processors anymore. I mean, it actually stopped, I think, in 2013. Why is that happening? That's happening because there is actually no need for that. I mean, there is some need to uh, do, build very powerful processes and then so on, but you can't really make much money out of building it, because in part due to virtualization and other technologies, right? You're trying to get more from the same. I mean, our laptops are not getting more powerful. That's why what's happening is they're adding more cores. Now it's like in dual core and then quad core and then so on, like 8 cores now, right? So that's how it is moving into resource isolation. Resource isolation is a big thing that uh, is actually facilitating more adoption and more trust primarily. Standardization and portability. So one of the good things, right? And one of you talked about being these applications being portable across clouds. And what do you need for that to happen primarily, right? You need standardization. So containers means the same thing right across, right? So Kubernetes is the same thing right across. So that is standardization and portability. Okay. And then containers came along. Okay. And the big thing about containers, again, whatever VMs have done to the machine, right? Now containers are doing the same to the virtual machine. In fact, it's getting. If you look at what container is doing, like some of the hypervisor virtualization layer is actually merging into the operating system itself. So uh, applications are now being hosted directly on containers. Okay. Now, what happened? How is container revolution taking off? Is because sometime in 2006, the Unix kernel began to embrace control groups and network namespaces, and that is again primarily about isolation. Okay. Now, portability is one big thing we talked about it, and cloud native. So, what cloud native is primarily about following some standard cloud native cloud practices. You have to make your software more portable. Okay. Now, just a bit of containerization, because containerization is catching up fast. Okay, and it wasn't there 5 years back. Now, when you think of containerization, it's primarily about standardization and portability, right? When a container ship lands and the same thing is going to sit on a train. I mean, the train doesn't have to bother about how big is the container. Do they really care? No, because it's all defined and standardized. It will just go and sit on the train and it reaches its destination and the truck takes over. But again, the key thing is here is portability. Okay, from ocean to tracks to railroad to roads, and all of this possible because of standardization. Now, we talked briefly about containers. We're not going to go deep. Some of you may understand, some of you may not understand. It's coming because every application development now is taking advantage of containers. So they're just isolated, lightweight operating system processes running on a host. But unlike virtual machines, containers don't need a hypervisor. So remember, we talked about the virtualization layer because some of the virtualization components merged into the operating system itself. Now, all the containers on the node share the same OS. So they're essentially processes. They achieve strong isolation using kernel features like C groups and namespaces and network namespaces. So previously, your one big machine hosted maybe 10 virtual machines, but now they are hosting 1,000 containers. Now, uh, the the thing advantage of containers is that they're packaged as an image. So once you have it as an image, it becomes highly portable. Now, this image concept increases portability. Now, when you're talking about containers, you also talk about container registry. It's like, okay, this is where I store all the images. Okay, so that anybody anywhere in the world can copy it and use it. Okay, and then remember back in the days, my days when I was not working on the cloud, it was this very common headache. It's like, hey, it works on mine, but it doesn't work on yours. The same piece of software. Okay, now how does that even come up? Because there is so much of difference in environment, libraries, and all that stuff. Okay. Now, just a second. Now, all that is passe. Okay, with containers, there is no concept of hey, it works on mine, it doesn't work on yours. That's dead for good. Okay. Now you also have, when you think about public cloud and then container, it's all about security also. Now you have services available to scan the container images for vulnerability. That means the software will scan your image and check for loopholes where somebody could exploit it. Right. Now it facilitates flexible CI/CD. CI/CD is continuous integration and continuous development. Okay. Now, okay, containers are becoming popular. Now, these containers and Kubernetes you will hear all the time because even in the public cloud, right, nearly 50% of the infrastructure runs on Kubernetes or containers. Okay. Now, you might not know that these days every application pretty much is running on containers. Very few are actually running on VMs. It's all containers. Now, Kubernetes came out of Google. It started as an open source. And why do you need Kubernetes? We need Kubernetes because you need to manage containers. There are like thousands of them. Okay. Now, Kubernetes also automates application deployment, scaling, and management. Now, previously, when you're designing your application, you had to worry about logging, monitoring, and what else? Resources, RAM going out of memory exceptions. All those are gone. You don't have to worry about any of those now if you start using Kubernetes. It's highly agile and extensible. In fact, any new job these days is nearly a mandatory skill. I mean, if you're in core development, right? I think without Kubernetes knowledge or content knowledge, you're not going to move forward. That's how it is. Because although you may not directly be coding, all your deployment is happening in Kubernetes. Now, they're highly agile and extensible because that's what Kubernetes provides. Desired state versus current state. It's like, you tell Kubernetes, hey, this is what I want, and Kubernetes will ensure that that state is maintained. Like, for example, your container dies for some reason. Kubernetes will automatically start one for you. Okay. Horizontal and vertical scalability. So remember, we always had horizontal scalability before. So being able to expand and provide more resources dynamically. So what about horizontal and vertical scalability? Okay, rolling updates with zero downtime. I mean, there's Kubernetes has got plenty of features. And now, if you look at what is happening now with Kubernetes, it's becoming the default operating environment on the cloud. So other than these databases and everything, right, any application on the cloud is now running on Kubernetes. Kubernetes is revolutionizing the infrastructure space. Okay, now Kubernetes is taking over everything. In the data center, this is like the default operating environment. It's not operating system, but default operating environment. And there's a whole lot of automation going on, of automation of application services installation, all thanks to Kubernetes. I mean, there are plenty of features. I'm just briefly touching upon them. Now, we talked about cloud and then public cloud and private cloud. Let's briefly touch upon this. So, to be classified as a public cloud, it has to be a multi-tenant platform. So, a public cloud is a multi-tenant platform that uses a standard cloud computing model to make resources like VMs, applications, or storage available to users remotely. Public cloud services may be free or offered through a variety of subscription or on-demand pricing. Okay, so one key thing when you say public cloud, well, public cloud anybody can use, but public cloud is a multi-tenant. Again, but private cloud is not a multi-tenant. So when you think about private cloud, okay, one of you asked the question, how do they set up? Yeah, so private cloud, one of the things is it's for your use only. It is not for public, and they don't care about multi-tenancy. They don't have to. That's the primary motive. But because of that, you have limited what is the services available. Okay, so it's a computing model that offers a proprietary environment dedicated to a single business entity or to a set of dedicated users, not general public. As with other types of cloud computing environments, private cloud provides extended virtualized computing services via physical components stored on-prem or at vendor's data center. So, you say private cloud, your resources can be on your company's premises, or it can be hosted. It's called co-located at some vendor's data center. But it's still private to you. Okay, so that's big thing. Multi-tenancy is there in public cloud. There is no multi-tenancy in private. Now, hybrid cloud. Now, what is this hybrid? So, hybrid actually can mean multiple things. So, when you mix and match private and public cloud, but why would this happen? Why would anybody do this? Like, for example, one of you talked about hospitals, and they're having a private cloud. So one of the reasons why somebody would want to do that is because they want to keep the data to themselves. They don't want to put the data on the private cloud. So data could be stored on-prem, but the applications could be running in the cloud. Now the advantage for that is that, assuming these applications are portable, right, you can actually keep switching from Amazon to Google easily, because the big cost of switching is your storage. Sometimes you have to encrypt, decrypt, and then load them. So that is an example of hybrid cloud. Now somebody asked about India's case, where Indian government wanted to Amazon signed up to provide cloud services. Now Indian government may follow this model where the data of all the citizens who could be on a government of India owned data center, and then there could be a tunneling mechanism, VPN, client of a situation where through the VPN they connect to Amazon cloud, and then all the applications would be running on AWS. The data per se could be storing on private cloud. Okay, so these are the top cloud providers. I think we talked about this briefly. Now, Amazon AWS is the largest cloud provider, and Amazon provides plenty of services. I mean, there are 200 plus services. Okay, very high penetration in the market. Okay, it has got. Amazon is a pioneer. Okay, and over $45 billion AWS annual revenue. Now, whenever you see Amazon, right, you see an arrow from A to Z. Any idea what that means? You can just, one of you can read out the answer. When you see an Amazon logo, it says there would be arrow starting from A and it ends at Z. What does it mean?
It's like A to Z.
They provide A to Z
A to
service?
Z. A to Z.
Yeah, but what exactly, how do you interpret it in common man's language?
You get everything.
It's
there.
like, yeah,
Everything is available.
Yes, we sell everything.
All services are available.
Yes. So similarly, when you say AWS, they say from A to S. You say an arrow from A to S. What does that mean?
Application to service, maybe?
Well, yeah, you're close. But essentially, if you see all the Amazons, yeah, that's application to service. But all the Amazon services, the name of the services will always be between A to S. Anyway, so but what services Amazon provides? I mean, anything in the planet they do everything,
including the rockets, right?
Yes, they're providing rockets, but I don't know whether you can book for a rocket on AWS, but maybe it will happen. Maybe you can book your journey in a rocket from AWS. So Microsoft Azure is another big provider, and this is the fastest growing. And one of the reasons why Microsoft grew so fast is because they had a lot of captive customers on Windows. All you need to tell them is, hey, come on, we are hosting on the cloud, come over and enjoy the party, right? So that's how Microsoft progressed pretty fast. So it's the second largest. It capitalized on businesses. Now, Microsoft doesn't split their cloud revenue. Microsoft doesn't tell us how much their cloud revenue is making, but from what I understand is that it is as big or it could be bigger than AWS. Okay. Now the other big provider is Google Cloud, the third largest, and it's fastest growing. And this is my personal favorite too, Google Cloud, because some of the technologies that Google provided, like Google made the biggest enhancements to networking infrastructure. Google's network is the largest. They have their own undersea cable, both even Azure, Microsoft, and Amazon also doing it. But Google connected all the continents physically through under the sea cable from North America to Europe, Europe to Africa, and Africa to Asia. They have undersea cables that will transmit data. Okay, future trends. This is happening as we speak now. So I mean, there's so many exciting that are happening. One thing is microservices. You must have heard about microservices. What the hell is this microservice? Right? Microservice came along because microservices take full advantage of containers. Okay. Now you have your monolithic application. You know, one big application does so many things. Okay. Now, when you move to the microservices model, all you do is you're getting very loose coupling, and then you split your application into small pieces. Now, why do you want to split the small pieces? Because they are very comfortable in a container situation, because you can bring them up fast and bring them down fast. And the advantage is that when you move to microservices, it's all about vertical and horizontal scalability. Now, previously a monolithic application, if you ask to scale, now you have to scale the whole thing. The whole thing will become bigger, right? But then, if you want only some services to become bigger, okay? Now, you see, we're all humans, we are of various sizes, but then there's something uniformity, right? If I grow fat, everything will grow fat in me, right? But let us say I just want my hand alone to grow like 1 feet extra, right? Now that will be a different thing altogether, right? Now that's something similar is happening when you move to microservices, because let's say you want to stretch and then catch something on the rooftop, and imagine your hand would magically grow. Okay. Now one way is the whole body growing taller is one thing, and your hand alone growing up is a vague analogy, but you can understand what is happening, right? So that would not be possible with microservices. Now again, serverless is coming up, and if you have heard of Lambda function as a service, this serverless concept is actually revolutionizing it, because now remember when you think about hosting in the public cloud, it's all about hands off, right? Remember before you were thinking like, I need 10 machines. Okay. Now with serverless, you can scale your application to 0 to infinity, and you don't have to worry about how much infrastructure you need. It's all being tossed out. So now if you're going serverless in cloud, you don't have to plan your infrastructure. So they're doing away with, okay, I would be needing 20 virtual machines or whatever. No, if you use microservices and you go serverless, you don't have to worry about infrastructure. You don't even have to do plan. You know, there's the concept of planning. I remember like we used to plan how many resources we need, scalability and all that. Now scalability is gone out of the toss. You don't even need to scale. It automatically does it by itself. That's serverless. Now multi-cloud and hybrid clouds, we talked about it. Now edge computing. Now this is that new thing. You must be hearing about edge computing all along. I mean, people have different definitions for edge computing, but I'll tell you the most common one. Essentially, your compute is now happening in the regional center. Imagine you're in the cloud, right? You have your data is coming from all around the world, and then now it is entering one region where you have zones and where your machines are doing all the processing. Now, edge computing is what's happening is you move compute to the edge itself. What is the edge? Edge is where the information is available on source. Now, you can take information from all over the country and then say process it in Hyderabad. Okay. Instead, the edge nodes are placed all around the globe, all around the country at various corners, and then they process the information and then send it to a central center. Let's say in Hyderabad, for example. I'm taking a central place. Now, edge computing is primarily shifting computing to the edge. Now, if you take about IoT devices, thousands of IoT devices are sending you data. Okay. Now, all these IoT device data will come to an edge computer, and it will do all the processing and only send that relevant information to the center. That's precisely what is happening. Now, when you think about edge computing, you don't need huge compute resources. In fact, edge computing is about a smaller device being able to handle your source, the data at the source. So that's what edge computing is. And now the other thing, it is coming up, VMs on top of containers. Now all along, your containers were sitting in VMs. Okay, now VMs are coming on top of containers. Now why is that happening? Right? Now we should talk asking about why should how is it? It looks like VMs on top of containers is more like tail wagging the dog. It's not like dog wagging the tail. It's like tail wagging the dog. So what happened is that with microservices coming up, getting popular, and companies who want to take advantage of microservices, okay, and they can convert their applications to microservice architecture. But a lot of companies are in a hurry. You know what? I just want to shift my application straight from VM onto a container. So one option would be that VM itself will come and sit in a container. Okay, it's not that common, but it's kind of catching up. DevSecOps. Now you must have heard about DevOps. DevOps is like your development methodologies and then your operations and networking merging together. Now security is a big piece in the cloud, right? When I'm going to the cloud, the security is a big piece. Now you keep hearing DevSecOps all the time, but something that you might want to remember. Okay. Now let's come to something that may be of interest to you guys about employment potential, right? Cloud technologies are expanding, and there's talent shortage in cloud technologies. And cloud technology provides a huge potential, and there are plenty of resources available. I mean, there's something that you can't ignore. Okay, if you have to get a job in IT, you need cloud technologies. There's no going around it. Now, I'm listing some of the resources that are available for free. Sorry. Now, Google Cloud gives you $300 in GCP resources for free. Now, if you sign up into Google Cloud and go to console, you'll actually see $300 credit. Okay, with $300 you can do a lot. Earlier, this $300 used to last for an year. They used to give 1 year to consume, but now they're restricting it to like 3 months, I think. Okay, but $300 will go a long way for you to consume them. And then, in fact, they're free. Try it out. I mean, you got nothing to lose, right? Same thing with Amazon. AWS gives away plenty of free training material and resources. With Amazon AWS, you can also get a free virtual machine, 750 hours, low-end virtual machine, and you can do a lot with that too. Okay, and with Microsoft Azure, you can get $200 of resources to start with, and again, you need to consume them in 1 month. So these resources, I mean, you can do a whole lot of learning. I think that's a big piece. Now, there is another company called Quick Labs. This is where, I mean, this is very interesting. Quick Labs gives you like, they'll give you like how to do this. I mean, you let's say you want to spin off a Kubernetes cluster and then build an application. Okay, how do you do it? Right? You need some help. You need some guidance. So the quick labs will help you to do that. They will there's a lot of free stuff. I mean, this is quick labs is not free, but once in a while they'll give out like freebies. Try this application for free kind of thing. And these are good learning resources. Yeah, question?
Sorry, I have muted that. Go on.
Yeah. Okay. So those are the learning resources. Yeah. So I'm came to the end of the presentation, and I think I kind of breezed through a lot in terms of making sure you don't take too much time. So any questions, guys? Or you just post it on the
Yeah. So yeah, thank you very much, Rama. I think you have covered very good content because I work in a cloud company and I work. I mean, my day in day out job is dealing with cloud based application, but still there are a lot of things I was not aware and I could learn from this session. So thank you very much. There is one question in the chat. Uh, how do I assess the need for cloud migration?
assess the need for cloud migration.
Yeah.
Okay.
I mean,
I'm not understanding the question.
So it is
okay.
more like
Okay.
when do I need to think about migrating to cloud rather than what I'm doing now with my own server, my own infrastructure.
Okay. How do I assess the need for cloud migration? Okay.
Yeah.
Now, one of the
sorry, Rama.
yes,
Before
let me answer this.
Yeah, before you answer that, can you can stop sharing if needed.
Okay.
Yeah, instead of seeing the desktop, or you can put the presentation on. Yeah, this is good.
Okay. Now, okay, let me actually read the question again. Okay, where did I go now?
Okay, I can repeat for you if you'd like.
Okay, this Zoom could be confusing. Like, where is the chat window? How do I get the chat window?
You can see on the bottom. You see the participants.
Okay, here it is.
Chat.
Here it is.
Yeah.
Okay.
You can see the question from Prasad.
How do I assess the need for cloud? Now, need for cloud. See everything that we are doing is you have to save money, right? What is the big criteria? You have to save money, save resources, go cheap, right? So remember we talked about converting your capex to opex. Okay. Now, okay, where is that question again? Okay, when you have to go to capex to opex, okay, so that's where you should start. How much are you spending? Okay, and how much you want to save? Okay, so then what how much you're spending on your on-prem. Now you make a list of all the resources that you consume. When you make a resource of all the consume, it should also include humans. You remember, the employee cost is the biggest. Okay, you have 10 people managing your cloud on-prem. Now go to the cloud, go to GCP, prepare a blueprint plan. How many resources you need? How many resources do you need on the cloud, on the prem? Same resources you put, and then you see how much savings that you make. And once you think the savings are significant, now you make the transition to GEM. Okay, so that's where it is. Primarily, it's about cost saving. And then when you want, think about the advantage that cloud provides, right? It provides you scalability, and they are self-managed. Resources on the cloud are self-managed, which means there's a value that you derive. Okay, now you have to put some monetary figure on that, because you'd be needing less number of people, right? You had 10 people now, but when you're going to cloud, you'll be needing only 2 of them, so which means a reduced cost. There's a whole Bible here. What does it take to move to cloud, and then assess the need. So some of the stuff that you can start is look at your hardware costs, your employee costs, how much you will save, and then make the transition if you think it's worth the move.
Yeah. Thank you. And there is one more question. Um, are there any regulation for cloud by United States government or any other government authority in the world?
Okay, regulation wise, see, United States government by far it's the one, it doesn't regulate much. Okay, now as far as clouds are concerned, there are some recommendations, mandatory. So there's something called FIPS, yeah, 5 years. I'll put it here. Okay, that's federally mandated practices if you're hosting anything on the cloud. Okay, and that is all regulation that I'm aware of. I mean, there are few other regulated based on the industry. For example, the credit card companies, financial companies, they have their own criteria. Healthcare companies would have this or whatever. They are individual ones based on the industry. Okay, so there are some recommendations and requirements, but they're not like tight regulation. I mean, regulation comes from the U.S. government. U.S. government doesn't really regulate that way per se. Okay, and is it not a business of monopoly? Can it give equal opportunity to all? I mean, I don't know. I mean, how do I interpret that question? Is it not a business of monopoly? Yeah, I mean, it's like, see, there are three providers, right? Within the years, there are three, and then Alibaba is coming up. I know how many of you are coming up. Alibaba is coming up in full thing, and there is Rackspace and IBM. There's plenty. There are at least 10 companies, so there's no monopoly. In fact, 80% of the market is shared by these three big guys, and yeah, maybe in future, right? There'll be only three companies that can do well on the cloud, and then a bunch of small companies struggling. But I don't think they're anywhere near a monopoly. So. In fact, you can start a cloud company and be a vendor for AWS, and there are a lot of companies like that. So you can start your own company and then source your AWS users from Amazon at a discount, and then sell it. That also is a business model that some of them are pursuing.
Good. Yeah.
So somebody asking about, Nagsen is asking about CSP dependency. What is CSP? I mean, what are it referring to as CSP?
It's a cloud service providers.
Okay, cloud service provider. Okay.
Yeah, I think that has been answered. So there is another question. What you suggest for move platform having 10 to 15 years of experience? Yeah, I think the question is on the career level. So a person who has 10 to 15 years of experience in the IT industry, would you suggest moving them to which platform you would suggest, like Google Cloud, Azure, or AWS? Which
See,
platform
one thing I want to tell you is like, see, one thing I want to tell you is learning is a lifelong thing. It's not for 10 to 15 years or 1 year or 40 years. It's the same thing. Because technology is changing. See, remember, nothing much has changed how refrigerators are designed. I mean, there some bells and whistles here and there, but the underlying, I mean, there's some electronics in the refrigerators now, but the primary is freezer. There's a freezing thing component, okay, and this automobiles have not changed in like decades till Tesla took over, right? And then everything is now a revolution is happening. So, but cloud isn't like that. Every year it changes, and if you're seeking, and every year new technologies are coming, and companies wants to become more efficient, and they want to reduce costs. So it doesn't matter that 10 years, 15 years. I mean, cloud is for you to embrace. You have no choice. So to move platform, I mean, have AWS, Google, learn anything. I mean, there are plenty of resources. You can learn all the three if you want. But because you have wealth of experience, see, at least in the United States, right? The job of sitting in a chair and then ordering people around, being a manager, those days are gone. In fact, even big companies, most employees, these are expected to be self-managed. There is a very distinct analogy between machines and software and humans. Okay, now software is becoming more self-managed in the cloud. Infrastructure is getting more self-managed. In big companies like Facebook and Google, right? Your boss is not going to tell you what you need to be doing. In fact, your boss may not interact with you that much at all. So you're self-managed, and you be productive yourself, and then you demonstrate that productivity to your company. That's where the model is coming. Okay, gone out those days that every Monday your boss will tell you, hey, do this for this week, and then you go and do it. No. So so if you want to, if you have 15 years experience, and you should be embracing cloud. I mean, not just cloud, right? See what is getting more popular. See what is in vogue, and what technologies are in demand, and then you switch yourself.
Yeah, thank you, Rama. Yeah, I mean, I agree with you. There are like plenty of opportunities out there wherever, but I think the basics are same, right? Basic concept of what is cloud and some of the
Yeah.
technologies that are underlying technologies for cloud. I think once we get those basics, I think it is changing the shirts, like change it from one
Yeah.
model to another model, right?
So, like for example, right? I mean, for most part, in your as a developer, right? You're 90% of the time you're doing coding work, and then somebody will do the deployment for you.
Mm-hmm.
Okay, the system admins, network admin, and then you're doing your system testing. You have to take your network admin guys to set up the testing infrastructure with multiple nodes and all that stuff. Now with the cloud, right, you're doing all that yourself.
Yeah.
See, when I first joined, when I was 2000, early 2000, when I changed, moved to one of the companies here, and first day, the system admin guy will come and set up a Windows desktop for you. You don't have to do anything. He'll come and then and then after a couple of days, another guy came in and set up the Linux machine. Okay, it's not going to be like that anymore, right? Now, if you want a Linux machine, you just go to the cloud and then sign up and then provision it yourself. Okay. Now, these network devices and everything, you have to provision that yourself. Nobody is doing that for you. So instead of doing 90% coding, you may be doing like 60% coding, and then rest of the thing you'll actually be focusing on infrastructure development. Now that's where this whole lot of automation has happened. Now, is Kubernetes, all these things are coming because to make your life simple. That's why once you're in the cloud, right, it's never like you're a developer, you're like DevOps. It's all DevOps, like DevOps, DevSecOps. You're worried about security and everything, and you design your applications. And cloud will help you to automate all those stuff. So your thought process will change. Your thought process that somebody will help me deploy this will change. You have deployed your tools. So which means a new learning language. Like I should make you the host. Okay, give me a second. Give me a second.
Yeah, that.
Somebody is asking, does it require technical degree? Give me a second. I'll answer that question.
Yeah, you can open participants and select my name there.
So technical degrees for cloud, learning cloud.
Yeah, just a second. Rashikar, I'll make you the host.
Okay.
Make host. Yeah, sorry. Okay.
Yeah.
Okay. No, okay. Yeah. So somebody is asking about, does it require a technical degree? So I will let the people from the industry have answered. Google says that you don't need a technical degree anymore. Okay, Elon Musk says you don't need a technical degree anymore.
Yeah,
okay?
That is right.
I've seen recent education is required.
Yeah, education is required.
If you have a passion, you want to learn different technologies, degrees won't stop you. But don't tell like you don't need degrees. You need degrees. Okay.
Well, yeah, you need, yeah, but yes, you can always improve. Maybe you need degrees. Remember, like in India, the locomotive driver is called engine driver in India.
Yeah.
But here they call it, in US they call him the same guy as engineer.
Yeah.
Okay, the locomotive engineer. That's the guy who actually drives. Now, whether you need a technical degree, I mean, a lot of people are now managing without it. And given that, see, learning is a lifelong thing. I mean, those are the days you have a 4-year study for 4 years and you don't never had to learn again. But you will now you will learn till you retire. It can be 40 years or 60 years or 80 years. Like you don't learn, you can retire at 40 or 30, even 30. In fact, one fear is that a lot of our current generation guys, they may retire by the time they're 35. They don't keep up with the technology. And not only technology, right? Even business is changing. There's a whole lot of automation going on. You no longer repair your TV, you no longer repair your refrigerator, you just throw it. And someday you no longer repair your car. In fact, one of the revolutionary things that Tesla brought about is the number of moving parts from like 3,000, 4,000 to less than 800. So what does that mean? I mean, you will need fewer people to repair your car. It will be a lot more easier, which means more fewer jobs. Now that's happening everywhere, not only in IT and manufacturing too.
Yeah, there is a Ram actually coming back to this coding and technology. There was one MD in one of the company I worked, a different financial company. So he was retiring. So they selectively invited some people, and I had opportunity to attend. And he took a question and answer, and he's extraordinary in terms of the business and the networking, public relations, and so somebody asked a question. What do you mean? What do you miss the most being an MD and after MD? And the guy said, I miss coding. He's like very successful MD. It's like, I don't think. And then in that context, he said, if you learn Python and cloud, some of the technologies, that's going to drive no matter what area you work, whether it's agriculture, aerospace, healthcare, this coding and the technologies is driving. So I just want to share.
Yeah, thanks.
Yeah. So I think
any more questions?
We didn't have any new questions. So I'm going to. So we have 10 more minutes. I think 9 more minutes. You have covered the fundamentals of cloud computing, and you have provided some good examples, like how we can see the cloud computing in the real world, like in our day-to-day life. Like we see some of them as software as service, when some of them as infrastructure as service, and you have covered good examples like the popular cloud platforms like AWS, Amazon AWS, Microsoft Azure, Google Cloud, and many others, right? And some you have covered some product like Gmail, Google Drive, like the basic application that we use in the day-to-day life. Also, you have covered some terminology about the Kubernetes, what are Kubernetes, and the virtualization, and the container analogy, and what are the new technologies coming up. So I think for those who are watching this recording later, you can go back and go through the presentation and the entire recording video. It has more details than what I've just summarized. So with that, for the next series, Rama, for the next part, what we can expect from this session, like what kind of topics you are going to cover.
Now I want to see the interest. Like see, we could go into Kubernetes and containers and deep, but whether people are ready to absorb it.
Okay.
Yeah. My approach is, Rama, approach is, you have done an excellent job in the introduction. My approach is, let's take the top cloud technologies. Let's take, AWS. You can cover AWS because now it is a dominant leader, and just like 101 AWS, and provide resource, provide certification guidelines, and then you can pick up the Azure. If probably we may bring up another friend to cover Azure while we are next to him guiding. So, yeah.
I understand. So, but I'm not a AWS guy, or I'm not a Azure guy, but I can
Google,
do Google Cloud.
Google Cloud. Yeah, that's
Google
what
Cloud. I can go into pretty much detail about what it can be a 1 hour session, and then I can give you actually resources. See, one of the big things that people may say is, how do I do this? And I can give a really take you on a drive, and then show you how you can access them and what you can do with it.
Yeah, I think so. We can plan that, Rama. Like we can take we can create a new email, brand new cloud account, and brand
Raj,
new
what we can
instance.
do is that what we can do is that this is because you are looking for a long term sustainability, and it's not like after 1.5 hours after Rama teaches and we are gone. Let's create a community where either through the Signal or WhatsApp, where people share ideas, ask questions. Let's create a community, because these days, when you're in a job, all of a sudden you had a design question, or all of a sudden you had an idea, but you're struggling, and you can quickly post in that group and say, hey, what do you think? What is your idea? And how to proceed forward. We need to build a community based on these sessions, and so that the learning not only happens in this session, learning also happens while interacting with other people.
Exactly. Yeah. Sure.
Yeah.
You brought up very good question, right? So what we can do is, for those who are attending this session today, right, and whoever is watching the recording live, our request is you can reach us, and we can create a group, maybe a Telegram group or Signal group, or a WhatsApp group. And WhatsApp is going to be limited one, so it is better to go for Telegram or WhatsApp or even a Facebook group, right? So you might have received this invitation from one of your friends or whoever. So you can reach out to me. My name is Rajshekar Kadari, or you can reach out to my colleague Raidas Mantena. You can find us in the Facebook, and you can reach out to your contacts, how you got to know about this session, and please get in touch with us. Let us create a community, like I said. It will help us to create a focused group, because in the introduction part, this is all basics, right? Anybody can consume this, but to plan the next session, we need to have a focused group, like who are all interested. Okay, say I know one of my friend comes back to me saying, hey, can we talk about more on the Kubernetes or virtualization, or what is this container analogy, right? So then we can come up with those topics, and then we can go on the focused approach, right? Because it is a kickoff session, it works well with this introduction and broader perspective. But the next and future session needs to be focused. So my request to all of you who are watching this or who are participating here is to please reach out to us. Let us create a focused group, and then decide on the topics that we need to cover, and let us work together to enhance our skills, and then let us grow together.
Yeah. In fact, Raj, once we build a community, it helps with the learning process. It also helps with the networking. Like somebody wanted to change a job, somebody has open positions, some friend has open positions. We can create and help support each other, because I have almost like 25 years of experience, gone through this whole process, and you have solid 15 plus years of experience. And we being coming forward doing this is to benefit not only the audience, it also benefits us. Tomorrow, I'm a manager in some place. I have an open positions. And these days, it's very hard to find qualified professionals. I post on LinkedIn, I post on my Facebook, I post on WhatsApps. And we have many WhatsApp groups for some subjects. And it's good to have something for career growth and development training.
Yeah, thank you, Rai. And Rama, so we will work with this focus group, and then we can touch base to see like what we can cover next. But at least for the next session, we can have a hands-on, cloud in the taking a Google Cloud as an example, and we can start with an hands-on like building from scratch, right? So that can be one session, and then in the meantime we can start working on this focus group and take the audience who are interested, and then take a deep dives into specific topics.
See, what I would we need to pick up at least a dozen or so core committed people who are willing to learn.
Yes.
And then we'll take it long term.
Correct.
Yeah. Leading into certification and leading into jobs.
Yes. Now, my experience, the last 3 years is like, they start off well. I mean, like 30, 40 people show up, like as it is today, right? And then slowly it will dwindle down. Now, I think those efforts will be fruitless if we don't last the life of the sessions.
Yeah. So, but Rama, on the flip side, okay? On the flip side, so today's introduction, maybe some of the seasoned guys have not joined because they know the introductory part of it. And when you start in the cloud, and there may be some from today, there may be a new set of people. So what we do is, as much as we have to see that how much information or quality of information we are sharing. In in fact, YouTube, the reason we also recording in YouTube is we want them listen to it at their own pace. So the purpose of these sessions, you've been doing these training sessions for a long time. The reason we wanted to collaborate is to reach much more audience. And I am going and listening to a video is definitely different from I am attending a session where listening through the speaker and some other audience asking questions are very effective. Yeah. And in fact, honestly, I expected 10 people. At some point, I saw a distinct 50 plus numbers. On average, we maintained 40, 45. And I know it is late in the India also. We'll see, maybe we'll start an hour early. We will figure that out. The first meeting, I wanted to see some response, but I'm very impressed with the quality of the content you presented, and also the pace you presented. And I'm very happy about this session. And thank you to Raj for doing all the coordination.
Yeah, thank you, Roy. So Rama, one final question.
Okay, one question that showed up here. Does it require have development knowledge to learn Kubernetes and containers? Now, technically no, because when you do Kubernetes and containers, right, you start off with, it's not about, it's about application hosting, but understanding the concept and being able to learn Kubernetes and containers, you don't need to have development experience. But again, you will be needing development experience sometime later.
Got it. Yeah, I think with that, let us conclude. We are reaching the top of the hour that is scheduled for. So once again, Rama, thank you very much for your time. This is amazing, and thank you very much for coming forward. We really appreciate all your efforts in preparing the slide deck and taking time to organize this session so well. And it is very educative and informative. Thank you again.
And also those who are attendees, if you're an expertise, you have a passion, energy to present and public speaking, please communicate to Ramakrishna, Raj, or myself, and your area of interest, your subject, and we can actually put you in the roster. Guys, there is no happiness that comes as close as sharing what you know. And a lot of people, when you say community service, we immediately think of money. There is a lot we can do with our talent and time. Please get encouraged. And this is a moral obligation for us to reach out to our communities in India and abroad. Thank you very much.
Yeah. All right. So thank you, everyone, all the wonderful audience. Thank you very much. And one thing I liked about this session is everybody is very, disciplined. Everybody were on mute, listening to the content very good, and there were very good questions. So thank you very much, all the audience as well. So with that, we are going to wind up the session at the
Yeah.
moment. Thank you,
Thank you,
everyone.
thank you, Ram. Thank you, thanks for your session. Thank you, Raj and Raidas.
Bala,
Thank you.
Bala.
Yes,
So the
yes,
burden
yeah.
is on you. Burden is on you to reach out to the UG and PG, undergrad and postgrad, and some of them, for some of them, see, you can reach out to the CROs. See, they can actually we put them into some structured programming.
Sure, definitely, Rana.